Again, remember that we're actually, this is simultaneous, but it is the nonlinear one, which means that it is going to turn into a quadratic curve. So this part is a quadratic curve and this part is a line. So let me just quickly show us what happened. So let us say, just a quick reference so that you can have an understanding. This is your y-axis, that is your x-axis. This one will give us something that looks like, say it looks like this, just roughly. And this one looks like that. So they will cross each other. Now what happened is, this is going to be a coordinate of a solution. There is an x value here as well as a y value. They walk together. Over here is another set of solution because that's where both of them cross path. There's an x value there, there's a y value there. So what we're trying to do here is trying to find those values. How it's going to work is, as soon as we start, it's going to turn into a quadratic equation where we're going to get either we solve to get the two x values first or we get the two y values first, any one of them. After getting that, then we are going to use it to get the other pair that walks with it. That's all. So we are going to end up with 4 responses. Each has its own. That's what is going to happen. How do we do this? Well, it is said that right now we have equation, say 1, we have equation 2, right? So what we could do is to create a third equation. All right, so I could say let y equal to some things, or I could let x equal to some things. Any one of them I want to do. So I'm going to let y equal to some things now. So I'm going to say y is equal to 3 and then a minus x. How did I get this? I subtract x from here and subtract x from this. So basically I use equation 2 to create equation 3, which means that now these two are actually the same thing, right? So I'm going to actually put 3 minus x in the first equation up here. This is where we're going to put it, all right? Because these two are the same. So I'm going to write a little note. I'm going to say I want to substitute. I intend to substitute 3 minus x for y, and I want to do it in equation 1. Why am I doing it in equation 1? Equation 1 is the one that I didn't touch. I'm going to write equation 1 now. 2x squared plus y squared equal to 33. This is my equation 1. But remember now, what I'm going to do is I will be substituting 3 minus x wherever I see y. So writing back this, which is 2x squared plus y squared. The y squared is going to be in bracket 3 minus x, and I'm going to square it, which is equal to 33. If you look at this point now, you realize that we only have one variable to deal with, which is the x variable. All right. So because of that, we know that we're good to go. We can go ahead and sort our thing out. Now, let us just look again. What we're dealing with now is that you're going to write back the 2x squared, but this part we need to square this. Remember, we just learned how we could square this easily. We can square this by saying 3 squared, which is 9. The negative x squared will become a positive x squared, because negative x times negative x is positive x squared. And then we could multiply these two things and double it. X times, so it's negative x times 3 is negative 3x. And when you double it, you get negative 6x. And that is how this is squared. All right. Now, for those persons who may not understand that, then you can just go ahead and do it the normal way. This is the normal way. We can FOIL it out, meaning 3 times 3, that's the 9. 3 times negative x, that's negative 3x. Negative x times 3, that's negative 3x. Negative x times negative x, that's positive x squared. And if you notice this, if I should simplify this, this is it. Same thing here. Look, we're getting the 9, we're getting the minus 6x and the positive x squared. So if you don't know how to do the squaring of a binomial, you could still set it up the normal way to get the response to move on. All right. Now that I have the response, I'm going to just quickly leave this here for a second and then remove it. Let us go further. This is 2x squared plus, well, let me just put everything together. 2x squared plus x squared, this is 3x squared. All right, agree? And then what we'll have now is negative 6x. And then we'll have a positive 9 and a minus 33. Because you could see that this 33 minus from both sides will be negative on this side. So let's see what's going on. Now let's rewrite this for the final take. 3x squared minus 6x. And then now you take that from that, and what do you have? What do you have there? 27? What do you have there? All right, so we're looking at 33 minus 9, we're looking at a negative 24, which is equal to 0. Now what we're going to do is, there are more than one ways you could solve these sort of problems, right?
Yes, sir.
All right, so this is what we have, but guess what? What I notice about these stuff is that we can break them down and it's not affecting anything. And what do I mean by break them down? Is that, this part, you can see that if we can divide everything by 3. And because you do that, it's not going to change your answer. The fact that we can divide everything by 3. So I'm going to reduce it so it looks simpler to work with. So if I divide it by 3, I'm getting x squared minus 2x minus 8 equals 0. So I have just transformed this big thing into a smaller version of its own self. So it's not like anything is going to wrong. It's going to be the same thing that you're working with. So what we're going to do now is to solve this, right? X squared minus 2x minus 8. Now it's a quadratic. We can factorize to solve. As you could see, the factors would be 4 and 2. I could use a 4 and a 2 to get out this, right? And it's going to be negative 4 also, because we would have learned those already. So basically we are looking at x squared minus 4x plus 2x minus 8 equals 0. That is me factorizing this very quickly. Let us say that you don't remember how to factorize. Okay, this is what I actually did. This is my x squared, right? And so we're saying that this is the negative 8 out here. We're going to try to find a replacement for the negative 2. All right, so it's AC. AC, as you could see, is going to be a negative 8 because 1 times negative 8 is negative 8. The numbers that can multiply to give you that would be these numbers, 1 and 8, as well as 2 and 4, right? 1 and 8 and 2 and 4. All right, 1 and 8, let me write it here, 1 and 8 and 2 and 4. These are the numbers that can actually multiply to give you the AC. Now, this is the only one that can give us a 2, understand? So then I'm going to let the bigger one take the sign of B based on what we learned already. And in that case, that is how I have negative 4 and a positive 2. Now we're going to do these, factorize this quickly. I could group that pair together. I could group that pair together. All right. So what am I looking at now? I am looking at x into this. This is x. X into the minus 4 is minus 4. I'm going to use positive 2. Positive 2 into 2x, that is x. Positive 2 into this is minus 4 equals 0. Let's write back everything. X minus 4 and then x plus 2. This is equal to 0. So we just factorize and now we're about to solve it. Now remember, two things multiply to give 0. Either x minus 4 equals 0, which means that x is equal to 4, or x plus 2 equal to 0, which means that x is equal to minus 2. So we can see now we have two values of x as we had explained earlier. So we got those two values of x, right? So being that we got those two values of x now, we can now go back and find the values of y for each of them. Because for each of them would have their own y values. What do I mean? We're going to investigate when x is equal to 4. When x is equal to 4, we're going to be using back equation 1 because y is equal to 3 minus x. And I want to know what is y when x is equal to 4. Okay, I put the 4 there. Y is equal to negative 1. What does this mean? Conclusion. When x is equal to 4, y is equal to negative 1. Understand? That's what we're saying. What it means is that these two were coordinates for the things that I was showing you earlier on. That was one of the coordinates. All right? So that's how we're putting it. All right, so that's that. Over the other side, let's take off this just to work out the next one when x is equal to negative 2. So there's another instance when x, so we want to study when x is equal to negative 2. Y is still equal to y minus 3 minus x. So I'm just going to put negative 2. Remember now, x is not 2, it's negative 2. So the double negative here, as you could see. So basically, we're going to end up with a 5 for y. We can conclude that when x is equal to negative 2, y is equal to 5. And there you have the other pair of solution, y is equal to 5. And as a coordinate, it would have been negative 2, 5 to be the other place that the solution would be. All right? So we're saying basically that's how it is, and that's the nonlinear simultaneous equation. It doesn't get harder than that.